Hello everybody, once again, welcome to your favorite night class. I'm Coach Knight. Today's lesson we're talking and discussing polynomial functions. We're going to determine the roots of polynomial equations and also apply the fundamental theorem of algebra. Man, that sounds important. All right, so our first example is actually going to be, we're going to skip down to example 2, but before we get to it, make sure everybody knows what a polynomial in one variable is. It's basically a multi-polynomial. There's only going to be one variable, but the trick is the variable can only have an exponent that is a non-negative integer. So no decimals for your exponents, no negative numbers for your exponents. It has to be a non-negative integer. The degree, kind of a vocab word here. The degree is simply the greatest exponent on its variables. Okay, so whichever variable has the biggest exponent, that is the degree. And the leading coefficient is the coefficient of the variable with the greatest exponent. So basically it's the exponent or the coefficient that's in front of the leading degree. Very, very simple. So example here, they give 10x, 1000x to the 18th plus 5x to the 10th plus 250x to the 5th. 18 is my degree because it is the highest exponent, and 1000 would be the leading coefficient because it is the number that's in front. Okay, so it's pretty simple, pretty straightforward. Let's try an example. So number 2, example A, 2A, says state the degree and leading coefficient of the polynomial. So again, the degree is simply the highest exponent, so that's pretty easy. The highest exponent looks to be 3. So my degree equals 3. And my leading coefficient is just the coefficient that's in the front of the degree. So the leading coefficient equals 1. Pretty, like I said, pretty straightforward. Part B on number 2, it says determine whether 4 is a 0 of f of x. Well, to be a 0, that means if I plug 4 in for x, do I get 0? If I get 0, it is a 0. If I don't get 0, it's not a 0. So I'm going to plug in 4. 4 cubed minus 6 times 4 squared plus 10 times 4 minus 8. I highly recommend you put parentheses around anything that you're plugging in. It makes life so much easier. Put this in your calculator. 4 cubed minus 6 times 4 squared plus 10 times 4 minus 8. And we get 0. So, to answer part B, the answer is yes. It is a 0 of the polynomial. All right. Next little section here, we're talking about polynomial equations. A polynomial equation is just basically when you take a polynomial function or expression and set it equal to something. The solutions for these polynomial equations are called roots. There's a lot of things that we call solutions. The solutions, you can say solve for the solutions. You can say solve for the roots. You can say solve for the zeros. All of these things mean the same thing. And that's what this little sentence is saying. It says the word 0 and the word root are used interchangeably. So if you're finding the zeros, you are also finding the roots. And if you're finding the roots, you're also finding the zeros. They basically mean the same thing. In Algebra 2, we learned about something called an imaginary number, and that's basically just when you take the square root of -1. And basically what you need to remember from this is that when you square I, when you have I squared, that equals -1, because that's how you're going to use that a lot to simplify things. So just remember, I squared equals -1. This is the complex number system. We start you off simple in Algebra 1, okay? Everything in Algebra 1 is real. So Algebra 1, you just kind of basically, you're kind of basically concentrating on these numbers, okay? That's the only ones you work with in Algebra 1. Then in Algebra 2, you discovered that there's this thing called an imaginary number. Pure imaginary numbers are simply just imaginary numbers by themselves. Complex numbers are basically all of the numbers. Complex numbers, it can be an imaginary number being added or subtracted from a real number. It can just be an imaginary number. It can be just be a real number. It can be any kind of number. So the complex number system is all the numbers that exist, okay? Even the imaginary numbers and the real numbers. And I'm gonna tell you that this is the last kind of numbers you'll ever have to learn, okay? There aren't any other numbers. I know you're like, well, first I learned we had real numbers and then there was this imaginary thing. There's no more after this, okay? You have learned all your numbers, finally. Complex numbers are all the numbers on Earth. So that brings us to our Fundamental Theorem of Algebra. And basically, it says every polynomial equation with a degree greater than 0 has at least one root in the set of complex numbers. So, I said what that says basically, and there's nothing basic to it. It sounds like mumbo jumbo, but all this is saying is if you have a polynomial equation, you're going to have an answer in the complex number system, okay? The number of answers will be the same as the degree of your polynomial. So if your polynomial is at third degree, if it's x to the third, you're going to have 3 answers in the polynomial, in the complex number system. If it's to the 5th power, you'll have 5 answers. If the highest degree is 4 and it's to the fourth power, you'll have 4 answers. Now, some of them may be real, some of them may be imaginary, but you're going to have a total of whatever your degree is, okay? You can also, these are just examples here, this degree of 1, all right? The graphs, also, when it has a degree of 1, the graph is only going in one direction. As you can tell, it's a line. It's only going in one direction. If it's a degree of 2, it will go in 2 directions. So this parabola, it goes down, and then it goes up. So you have 1 direction, 2 directions. So degree of 3, it goes up, and then down, and then up. 3 directions. And that works for all of them. 4 degrees, down, up, 4 directions. 5 degrees, up, down, up, 5 directions. They all do that. If it has 6 degrees, it's going to go up, down, up, down, up, down. It'll have 6 directions, okay? As you can tell, all of these, if I erase these here, every time it crossed the x-axis, that is a solution. That is a root. That is a 0. Remember, all these words mean the same thing. So a degree of 1 has 1 answer. A degree of 2 has 2 answers. Degree of 3 has 3 answers. Degree of 4 has 4 answers. And degree of 5 has 5 answers. Now, understand something. If it crosses the x-axis, those answers are real. But sometimes you have some that are real and some that are imaginary. So down here we have examples. This is a degree of 3, but there's only 1 x-intercept. So what does that mean? That means there's only 1 real answer. Okay? Well, there's 3 total, So that must mean there's 2 imaginary. Okay, and imaginary answers always come in pairs. Okay, you will either have 2 imaginary answers or 4 imaginary answers or 5 imaginary answers, or excuse me, 6 imaginary answers. They always come in even numbers. Okay, you can never have an odd number of imaginary roots. All right, so this is another example. This is a degree of 3 also, and there's only one x-intercept. This is the real solution. And we don't know what the 2 imaginary are, but they've got to be 2 imaginary because we've got to have 3 total. Okay, 4, degree of 4 right here. It crosses the x-axis twice, so there are 2 real, which means there must be 2 imaginary as well. Because again, all the numbers have to add up to 4. All the roots have to add up to 4. The last one over here, as you can tell, it doesn't cross the x-axis at all. So all 4 roots are imaginary. Okay? So just keep that in mind when you're working these out. It'll help you along the way. Now understand, you are going to be asked to, example 3 here, write a polynomial equation of least degree with roots 2, 4i, and negative 4i. Now, this is a little lengthy sometimes, depending on how many roots they give us. So they have roots 2, 4i, and negative 4i. So that's 3 roots. So that means this is going to be a cubic, okay? And here's how you work it out. So if you have a root of 2, that means x minus 2 was a factor. If you have 4i as a root, that means x minus 4i was a factor. And if you have negative 4i as a root, that means x plus 4i was a factor. Okay? So understand the difference between roots and factors. You've done this before, back when you solved quadratics. Let's see if I can't just make one up real quick here. All right. So if you have a quadratic and you want to solve it and you can factor it, you can put it in the quadratic formula, but it's a lot quicker just to factor it, and you factor it by getting what 2 numbers multiply to be negative 2 and add up to 1, and that'll be positive 2 and negative 1. And then you set both of these, that's our factors, and then to get the answers, to get the solutions, you would set them both equal to 0. So x equals negative 2 and x equals positive 1. So these are my roots right here. And then if you work backwards, you get your factors, okay? They are always opposites of each other. Okay, so right here, that's all I did. I knew we had a root of 2, a root of 4i, and a root of negative 4i. So I just changed the signs and put them into the parentheses, okay? And now to get my polynomial equation, I just work it out. So I'm going to leave my x minus 2 here, and I'm going to FOIL these imaginary answers. Now, these are what's called conjugates, and when you multiply 2 conjugates, the imaginary answers will always cancel. So let me show you how this works. So you have x times x is x squared, x times 4i is 4xi, negative 4i times x would be negative 4xi, and negative 4i times 4i is negative 16i. Squared. Okay, negative 4 times 4 is negative 16. I times I is I squared. So, when we simplify this, 4xi and negative 4xi cancel. So they go away. And I'm left with x squared. And now here's what I was talking about earlier. I squared equals negative I, or negative 1, excuse me. So this is like saying negative 16 times negative 1, which is positive 16. And then we multiply that out one more time. So x times x squared is x to the third plus 16x minus 2x squared minus 32. And you just want to make sure you write that in the right order. You always want to go highest exponent to smallest exponent for it to be correct. So this would be my polynomial equation of least degree. Okay. Part B says, does the equation have an odd or even degree? How many times does the graph of the related function cross the x-axis? I could have answered these questions before I even worked all this out, okay? First off, is it odd or even? Well, how many roots did it have? It had 1, 2, 3 roots. Well, that means it's an odd degree. Okay? All right, and then it also said how many times does the graph of the related function cross the x-axis? Well, we talked about this earlier. Every time it crosses the x-axis is a real answer, a real root. So how many real roots does it have? It has 1 real root. The other 2 are imaginary. So the answer to how many times does the graph of the related function cross the x-axis, that is just once. Okay, it crosses 1 time. And that's all you had to do on those. Okay, so number 4, example 4 says state the number of complex roots of the equation, then find the roots and graph the related function. So I'm not going to make you graph any, okay? So if it says graph in the directions, just ignore it. But you do need to state the number of complex roots and then also find the actual roots. So when we go to state the number of complex roots, that's the easiest part of the question. So it's just your degree. So this degree is a degree of 4. So we have 4 complex roots. And then to figure what those are, we factor. So 9x to the 4th minus 35x squared minus 4 equals 0. And we kind of work this out. They don't start us off easy. This is very similar to a quadratic equation. So I'm going to work it as if it was a quadratic equation, only at the very end there will be a little bit different. So first you always look for a greatest common factor. There's not one. So what I do is I borrow. I don't know how your teacher taught you, but I borrow the 9. And we're going to take this 9 and we're going to move it over to negative 4. So now it becomes x to the 4th minus 35x squared minus 36 equals 0. Now understand, I'm just borrowing it for a second. And how did I borrow it? I moved the 9 and I multiplied it by the 4. Then I factor. Now normally we have x and x here, but since it's x to the 4th, I'm going to have x squared and x squared. But we do the same thing as far as the numbers go. What 2 numbers multiply to be negative 36 and add up to be negative 35? That's negative 36 and positive 1. And then to get my final answer, I just set, well, I'm sorry, I almost forgot. I said I was going to borrow the 9. So I borrowed it by multiplying it. I have to put it back by dividing. So this will reduce to x squared minus 4. And this reduces to x squared plus 1/9 equals 0. And to get your answers, you set both of these equal to 0. So x squared equals positive 4. I take my square root. X is plus or minus 2. X squared equals negative 1/9. I take the square root. Messed up. I said 1/2. It's 1/9. Sorry. Ugh. Take the square root, take the square root. So x will be plus or minus 1/3. And since it's negative, it is imaginary. So these are my 2 imaginary roots. And over here are my 2 real roots. And 2 imaginary roots plus 2 real roots equal 4 total complex roots. Okay. At this point, that's everything you're doing today. I'm going to continue on with the video if you want to keep watching. and do a few more examples real quick. I think, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9 quick examples that I'm going to show you. And here we go. So the first one, state the degree and leading coefficient of each polynomial. So these are very easy. The degree here is 3. It's just the highest exponent. The leading coefficient is the coefficient that's in the front of the highest exponent. So that's 1. For number 6, the degree, again, highest exponent would be 5. And the leading coefficient in front of that 5 is 8. That's all there is to those. Determine whether each number is a root of x to the third minus 5x squared minus 3x minus 18 equals 0. So if it's a root, it has to equal 0 when you plug it in. Okay, so with 5, I'm just going to plug it in. So we have 5 cubed minus 5 times 5 squared minus 3 times 5 minus 18. Does that equal 0? Well, we simplify it. Let's see here. That would be negative 33, and negative 33 does not equal 0. So this one would be no. It is not a root or a 0, however they say it. Let's try 6. So 6 cubed minus 5 times 6 squared minus 3 times 6 minus 18. We put that in our calculators. Let's see here, 6 cubed minus 5 times 6 squared minus 3 times 6 minus 18, and we get 0. So the answer for this one is yes, it is a root. So if you plug it in and you get 0, it's a root or a 0. If you plug it in and you don't get 0, then it is not a root. Okay. Number 9, we have 2 zeros. It says write a polynomial equation of least degree for each set of roots. Does the equation have an odd or even degree? How many times does the graph of the related function cross the x-axis? So I can answer these last 2 questions first. Okay, so the last 2 questions, does it have an equation have an odd or even degree? That's just you count how many roots does it have. So number 9 has 1, 2 roots. Therefore, it has an even degree. And then it says how many times does the graph of the related function cross the x-axis? Well, how many of the roots are real? In this case, 2 of them are real. They are both real. Now, to write the polynomial equation, we take our roots and we make our factors. So that'll be x plus 5 times x minus 7. You do the opposite, okay? And then you just multiply it out. So that's x squared minus 7x plus 5x minus 35. And then you add your like terms, and you're done. That is your polynomial. Okay, 10 is a little longer, as you can see, but this first part again is very simple. It has 1, 2, 3, 4, 5 roots, so therefore it will be an odd degree. And how many of those roots are real? 6 is the only one that's real, so that we'll be crossing the x-axis just one time. And then to figure out the equation, we're going to plug them in. This will take a little while because there's 5 roots. The more roots you have, the more multiplying you got to do. So we're going to have x minus 6. Again, this is number 10. X minus 6 times x minus 2i times x plus 2i times x minus I times x plus I. Again, I'm just doing the opposite to make the factors. And then I multiply them out. Multiply the conjugates together, That's the easiest thing to do. If you can remember this trick, the conjugates will always cancel out the imaginary numbers, okay? So in the middle, they'll cancel. I'm going to show you the long way. Oops. So we're going to have x times x is x squared. X times 2i would be positive 2xi. Negative 2i times x is negative 2xi. And then negative 2i times 2i is negative 4i squared. And as I said, the imaginaries, the i's cancel. This I squared is negative 1, so that will end up being x minus 6 times x squared plus 4. Negative 4 times negative 1 is positive 4. So, since we know this middle part always happens when you're multiplying conjugates, they always go away, and this back part always becomes positive, you can kind of shortcut. You can make this a shortcut. So I know this is going to be x squared plus 1 here. Now, if you want me to multiply it out, I will. X times x is x squared. X times I is xi. Negative xi cancels, and then negative I squared. So negative and negative 1 is positive 1. And then we multiply again. So this will be x minus 6 times x squared is x to the 4th. X squared times 1 is x squared. 4 times x squared is 4x squared. 4 times 1 is 4. So that reduces to x minus 6 times x to the 4th plus 5x squared plus 4. And one more time, x times x to the 4th is x to the 5th. X times 5x squared is 5x cubed. X times 4 is 4x. Negative 6 times x to the 4th is negative 6x to the 4th. Negative 6 times 5x squared is negative 30x squared. And negative 6 times 4 is negative 24. And then you just need to rewrite your equation in the right order. So minus 6x to the 4th would come next, and then plus 5x to the 3rd minus 30x squared plus 4x minus 24. Like I said at the beginning, the more roots you have, the longer your equation will be. Okay? Notice my degree is 5, it's odd, and I only had one real solution. So number 11 says state the number of complex roots of each equation, then find the roots. Don't worry about graphing the related functions. You just have to find the roots. So they give us a pretty easy one here. So how many complex roots are there? There are 2, because the degree is 2. So 2 complex roots. And they want us to solve for them. So I am going to factor what 2 numbers multiply to be 49 and add up to negative 14. That would be negative 7 and negative 7. And so x equals 7. It actually equals 7 twice, but there's no reason to write it down twice. Okay? Number 12 has an exponent of 3 for its degree, so there's 3 complex roots. And by the way, the 7, we only write it down once, but it is 2 complex roots. You do get 7 twice, so it's still correct. We still have 2 roots. It just happens to be the same root twice. And when that happens, it's called multiplicity. This one would have a multiplicity of 2 because 7 happens twice. Sorry, I forgot to mention that. So there's 3 complex on 12. I can factor out a first. So I'll have a squared plus 2a minus 8 equals 0. And then I believe I can factor out that trinomial. 2 numbers that multiply to be 8. two numbers that multiply to be negative 8 and add up to 2 are positive 4 and negative 2. And now that we've got our factors, we just set them equal to 0. So one solution, or 1, 0, is x equals 0. One solution is x equals, or a equals negative 4, and one solution is a equals 2. And then last but not least, number 13 has 4 complex roots. And to solve it, no factoring to do here. We're just going to set it equal to 0 and work it. So move the 1. So this would be the t to the 4th equals 1, and we take the 4th root of 1, and that will actually be plus or minus 1. And technically we get positive 1 twice and negative 1 twice, so we have 4 answers. The positive 1 would have a multiplicity of 2, and the negative 1 would also have a multiplicity of 2. So hope this video helps. Enjoy doing your homework problems, and contact me if you have any questions. As always, stay above the line.